Super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano. If nature had its own movie, it'd be a mix of Avatar and Interstellar. And I'm not even kidding. How else could you explain something as surreal as avalanches that spark blue light or pink lakes? The thing is, these aren't CGI, and I'll show you how Earth manages to pull these off. In October 2024, a guy was lucky enough to be at the right place during the right cold night and got to record a blue avalanche. I mean, it was mainly white, but it quickly flashed a blue light while it was running downhill. Now, scientists aren't totally sure how these blue flashing avalanches happen, but they have some ideas. One part of the mystery comes from a thing called Bioluminescence, which is when light is created by rubbing or breaking something. It can happen on many different occasions. One of them is with ice structures. This happens because of friction, like when two things scrape against each other, causing a little bit of sparks to appear. It's a cold light, meaning it doesn't come from heat, just from pressure or movement. Sometimes when ice cracks or breaks under pressure, it can make a tiny electrical charge. When something disturbs ice blocks, making it crack, this ignites a reaction. The trapped ions are charged particles, and when they suddenly get released, they start moving around. This big release of energy is what creates flashes of light. In this case, a blue glow or flash of light. All of this happens absurdly fast, so to actually witness this release of light is super rare. In June of 2024, people in the US witnessed a massive emergence of cicadas that only appear once every 13 or 17 years. Cicadas spend most of their life cycles underground. While they're still nymphs, they can spend multiple years feeding on tree roots. Some species can spend up to 17 years under the earth before they're ready to re-emerge to the surface and officially turn into adults. But 2024, both 13-year and 17-year-old cicadas appeared at the same time. And since 13 and 17 are prime numbers, this event only happens once every 221 years. The forests got absurdly loud. You see, cicadas can sing anywhere as loud as 80 to 120 decibels. They usually sing in groups, which is why it tends to get pretty loud. Someone who actually lived through this event said they could yell at full strength while inside the forest and not hear themselves at all. When cicadas come out of the ground, the male insects produce loud songs by vibrating their abdomens to attract females. With millions of insects from both species singing together, you were in for a real-life natural symphony. Some people mistook these cicadas for locusts and called it an infestation. All the way down in Senegal, Africa, lies a unique lake. Arriving there, you might think you're walking out of a spaceship and into an unknown planet. After all, have you ever seen pink water before? The so-called Lake Retba, or Lac Rose, as known by the locals, has become internationally famous for shining its vivid pink color. And yes, you can swim there if you'd like, but you should know the water is extremely salty. Lake Retba is known to be one of the world's saltiest lakes, with a saline level of about 40%. And in case you're wondering why the water is pink, I assure you this has nothing to do with otherworldly factors. It's actually due to the high levels of salt. The algae, known as Dunaliella salina, is the one responsible for the pink shading. These algae produce red pigments that absorb sunlight, giving the lake its striking pink color. But if you'd like to catch the lake at its brightest color, you should go during the dry season, between the months of November and June. In other months, the rainwater dilutes the pigments and its color becomes less distinct. You can also find a bubblegum pink lake in Western Australia. It was actually crowned as the 10th most otherworldly sight in the world. Lake Hillier is shaped like a footprint and measures over 1,900 feet in length. You can really see how the pink stands out next to that deep blue ocean sitting next to it. Hey, look here! Any ideas what this is? Take your wildest guess. Okay, it looks like a river, right? But that doesn't look like water flowing on it. When locals first saw this happening, they didn't know what it was. So, to make things easier, they just called it Sand River. It sure was a good guess, but it turns out that what these people saw is more or less an optical illusion. It's not sand, but it's not exactly water either. You see, in arid environments, it's pretty rare for hails to happen. And in this case, what we're seeing are thousands and thousands of floating hailstones. Simply put, hail is just frozen rain that pours down in the form of small pebbles of ice. Looks pretty magical though, doesn't it? Now, isn't it crazy that something as beautiful as the Northern Lights emerges from a violent encounter? Yep, The so-called aurora borealis is actually the result of solar storms. Here's how it works. The sun, the giant ball of gas, sometimes throws out bits of plasma into space. When this plasma flies away from the sun, we call it a solar storm. These storms travel through space, passing by planets like Mercury and Venus before reaching Earth. When these intense solar storms hit the Earth's magnetic field, something amazing happens. These particles coming from the sun are captured by Earth's magnetic field. They collide with atoms and molecules in the Earth's atmosphere, and these collisions create auroras, especially near the north and south poles. From where we stand, these flashes look like colorful lights dancing in the sky. But that's not really what's happening. If you zoomed in, you'd see millions of tiny flashes happening super quickly. Oh, and the northern lights make sounds too. It's a mix of chirps, crackles, and buzzing noises, like a strange radio signal. And this is the sound of a solar storm crashing into our atmosphere. Does Thor ring any bells? I'm guessing he lives inside this next natural phenomenon. The thing is, sometimes when a volcano erupts, it can be accompanied by huge thunderbolts. Scientists often refer to it as volcanic lightning, and they're still debating as to why this happens. One of their guesses is that when a volcano erupts, it projects charged debris into the atmosphere. These charges then react with other charges already present in the air, which can result in a bolt of lightning. Cool, huh? The first time anyone ever witnessed something like this was during an eruption of Mount Vesuvius in 79 CE. Last but not least, rainbows. Of course, which is the semicircular one we see most times. If you're lucky, you can witness a full circle rainbow, which usually happens in high altitudes, where the line of the horizon doesn't cut the rainbow in half. Ah yes, there's also the possibility of a lunar rainbow, aka the moonbow, which is a very unusual sight. It happens usually during full moons, when the light of the moon is at its brightest, and it's also perceived as a white arc, outlining the moon's outer rim. Let's just wow here for a moment.
Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river. but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the US. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle megafloods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together. We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hotspot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called mushroom pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud pots, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1,800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea, but sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be, and the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight. If you've ever been to Yellowstone National Park, you were probably mesmerized by its geysers, which spew superheated water and steam high into the air. But an even more intriguing thing actually hides underground. I'm talking about that underfoot plumbing system that makes those grand eruptions possible. About that, there's good news. Recently, researchers have succeeded in mapping the national park's hydrothermal plumbing system with the help of a giant flying magnet. As a result, scientists have managed to document all these features in stunning detail. The thing is, Yellowstone houses the world's largest hydrothermal system. It contains over 10,000 features, like geysers, mud pots, hot springs, and steam vents. They're fed by a network of underground water pathways. Those get overheated by magma flowing underground. It causes the water to rise to the surface. Now, no one actually knows much about the workings of this system, but the newly created maps might finally shed light on it. Experts explain that their knowledge of Yellowstone has a subsurface gap. That's why it's often called a mystery sandwich. Scientists know quite a lot about the features on the surface because they can observe them directly. And they know what's going on in the magmatic and tectonic system several miles below the surface. But they haven't figured out what's happening in the middle yet. So, I must tell you about that giant flying magnet used for research. It's known as SkyTem. It was attached to a helicopter and flown over Yellowstone several hundred times, scanning the ground below. The magnet is made up of an 82-foot wide charged wire loop. Its main task is to generate a strong electromagnetic field. And since different kinds of material, like water or rock, respond to this field differently, scientists managed to create a few subsurface maps for the first time ever. The mapping technique also allowed the researchers to differentiate between magma and bedrock, since they have a bit different magnetic properties. And the team got a chance to see how the magma and water interact and create those mind-blowing geological features on the surface. The team got high-resolution maps to a depth of around 500 and 2,300 feet, and low-resolution maps showing what's going on at a depth of up to 1.5 miles. At the same time, the researchers think that the hydrothermal system itself may stretch as far as 3 miles below the surface. If they're right, it means they've only mapped the top half of Yellowstone's plumbing system. Anyway, remember how I said that scientists know pretty much about the bottom part of the Yellowstone sandwich? They have such a good idea about the tectonic plates and deep fault lines because the park's frequent earthquakes provide them with a lot of opportunities to study different phenomena. In July 2021, for example, more than 1,000 earthquakes rocked the area. These days, the team of researchers knows much more about some famous features, like the Old Faithful Geyser or the Grand Prismatic Spring. They've also found out that individual hydrothermal features on the surface can actually be connected to others, which can be as far as 6 miles away from them. Another interesting discovery is that even though Yellowstone geysers and hot springs vary in size, shape, color, volatility, and chemical composition, they are mostly fed by very similar underground sources. That means that the difference between the features appears closer to the surface. Now, I'm sure you've seen the iconic image of Yellowstone with a large rainbow-colored spring, fiery orange at its edges. So what makes these hot springs so colorful? Surprisingly, these awesome hues come from microscopic creatures. The temperatures in the springs are so high they can easily and quickly cook you. Plus, the water there is super acidic, like the liquid in a car battery. But there are certain types of heat-loving microbes that don't mind these crazy conditions. You can even say they're thriving there. So every ring of a different color is, in most cases, a ring inhabited by different bacteria. And each species is adapted to a particular temperature or pH level, which measures how acidic this or that environment is. For example, take the Grand Prismatic Spring, yes, the iconic one. Its rainbow hues likely hint at the diversity of microbes living there. So, starting from the center of the hot spring, you can see a beautiful aquamarine color there. That's where the water temperature is the highest, reaching 189 degrees Fahrenheit, because this area is right over the underground water source. The water there is too hot even for microbes. That's why what you see is mostly clear water. As for the reason for its blue color, it's the same as why the sky is blue. Sunlight hits the surface of the water and the light scatters, but the blue light scatters the most, getting reflected back to your eyes. Now, the next ring of color is yellow, all thanks to certain cyanobacteria. The temperature in this yellow ring reaches 165 degrees Fahrenheit. If the conditions in the hot spring were a bit different, these bacteria would create a blue-green hue, thanks to a green pigment called chlorophyll. But since the sunlight hitting the spring is too intense, the bacteria start producing another type of pigment. It's called carotenoids. And guess what? It acts as a sunscreen for the bacteria. And since this pigment is orange, the normally green bacteria get a yellowish hue. And finally, we've got that bright orange color closer to the edges of the prismatic spring. It's a bit cooler there, around 149 degrees Fahrenheit. In this part of the spring, you can find several types of bacteria. They all produce substances that give the spring this bright orange color. And finally, right at the edges of the spring, the temperature is cooler, around 131 degrees, and a greater variety of microbes can survive there. All of them combined give the edges of the spring that red-brown hue. But scientists believe that people and their activity may have influenced the colors of Yellowstone's hydrothermal features. For example, in the past, the temperatures in the Morning Glory pool used to be much higher than they are today. That's why its color was a deep blue. But trash has started to accumulate in the pool, and some of it clogged the vent. This caused the temperatures to drop, which led to microbial growth. As a result, that pretty blue color turned into orange-yellow. As for Yellowstone's geysers, the most famous one is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than the others, erupting about 20 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach a height of 180 feet. Now, while talking about Yellowstone National Park, we can't but mention Yellowstone Supervolcano, right? Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. You don't necessarily want to be around for that. Over the past 50 years, the Yellowstone caldera has risen almost 3 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. There have been at least 3 other super eruptions in the history of Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago, long before video. The most recent super eruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spilling out 240 cubic miles of rock, dust, and volcanic ash. No thanks, I'll pass.
If you were visiting Earth from another planet, your rational mind just wouldn't understand how singing dunes and moving balls of lightning were scientifically possible. I bet you'll feel like these images are just stills from your favorite sci-fi movie. You better hope you never find yourself alone near Catatumbo River in Venezuela during one of its lightning storms. Because if you were, you'd be surprised to find out that lightning works both ways, meaning it can come from the sky and from the ground. Terrifying, I know. Scientists think that in this case, it probably happens because of a high presence of uranium in the bedrock. But it can also happen due to cold and warm air currents that meet around that area. This makes the electric field get all charged up and the bolt flips, traveling from ground to cloud. Scientists even have a fancy name for it: upward lightning. This special place called Catatumbo River became famous because of its light shows. Actually, the name means House of Thunder in the local language. This phenomenon happens for up to 160 nights a year, and it can last around 9 hours a day. When scientists counted, they realized that the area could produce anything from 16 to 40 flashes of lightning per minute. Now, you've probably heard of Marco Polo, the 13th century Venetian merchant and world traveler. Well, in one of his voyages, he came across what he could only describe as singing dunes. The dunes literally started rumbling like they were playing drums and freaked him out so much he thought it was the works of evil, invisible entities messing with him. Fast forward to our times, and scientists have discovered how sand dunes produce these rumbles. A team of scientists studied a singing dune in Morocco. They chose a large, crescent-shaped one that makes noise all year round. If the wind is right, this dune can sing a few times every afternoon. It turns out that the wind forces sand to accumulate at the top of the dune until the angle of the slope reaches a tipping point of about 35 degrees. This accumulated sand drops down like an avalanche, and that's what produces a sound. The sand needs to be dry enough for the singing to happen though. They're like nature's boombox. Isn't that something? This next one might be the most disturbing of them all. First, you'll see a flash of lightning. Then, a thundering boom. And finally, a curious light floating through the air and bouncing off surfaces like a white electric ball. Would you also hide under your blanket if you witnessed something like this? That's what an old lady did when she witnessed this from bed in her Chicago apartment. It turns out, people have been swapping their own ball lightning stories for hundreds of years. An English monk's report from the early 1000s might be the oldest version of these accounts. It talks about a fiery globe descending from a storm cloud and falling into the river Thames. The thing is, scientists aren't entirely sure what causes it, but one theory involves lightning striking silica-rich soil. This can vaporize silica, creating tiny particles bound by electrical charges. When these particles react with oxygen, they produce glowing orbs, which can last a few seconds. Some other theories say that it can be linked to miniature black holes, or even hallucinations. But the silica explanation is the best contender so far. What they know for sure is that ball lightning is often linked to stormy weather. If you'd wake up in the middle of a wintry night and saw these lights, you'd probably think otherworldly people were invading our world. Or you'd feel like one of the lucky people who got to see the northern lights during your lifetime. But none are correct. These beautiful shafts of pastel-colored light were photographed by a guy in Ontario, Canada. They happen when tiny, flat ice crystals that usually reside up in the atmosphere float closer to the ground. They're sometimes called columns of violet light, and they reflect light from sources like streetlights or cars. These reflections stretch into tall, colorful columns that look like they're glowing in the sky. The best part is that it's mostly an optical illusion. The pillars aren't really in the air. They're just a trick of light bouncing off the ice. Somewhere near Buffalo, New York, you'll find a surreal combination of the fire and water elements. This phenomenon is called the Eternal Flame Falls, precisely because it never stops burning, even if it's so near the water. This is due to a chemical reaction where gas leaks out of the ground and combusts with the air. It's one out of a few hundred natural eternal flames around the world. But the 30 feet tall waterfall is probably the most beautiful one. Now, how does it get lit the first time around? Usually, eternal flames can be ignited by lightning, human activity, or something called piezoelectricity, which is basically when certain materials make electricity when you squeeze, press, or twist them. Scientists believe that Native Americans lit these flames thousands of years ago, but that's just a hunch. Have you ever imagined going for a midnight swim and suddenly finding yourself surrounded by a glowing blue haze? As if there were huge cannons of light coming out of the seabed directly into the surface. This phenomenon is rare, but it sure is magical. This chemical reaction is known as bioluminescence, and it can happen in different situations. One example is when tiny algae organisms migrate near the seashores. When these algae are disturbed, they try to defend themselves by glowing, and just happen to create the most beautiful spectacle. There's also a specific place in the world where you can see a similar phenomenon. It's in New Zealand. Hidden deep within the country's caves lie the so-called glowworms. They are the larval species of a fungus that happen to be luminescent. If you're lucky enough to tour around these caves, you'll feel like you're floating inside an underground galaxy. The sky can create lots of different cool phenomena, and this specific one is called a crown flash. If you were seeing it with your own eyes, you'd see a column of light jumping or dancing near the top of a cumulus nimbus cloud. Think of cumulus nimbus as massive, towering clouds that look like fluffy mountains. These are the clouds that usually announce thunderstorms, lightning, and heavy rain. Now, although you'd probably think crown flashes looked like some supernatural energetic door opening to the heavens, this is a very scientific phenomenon. It happens when sunlight reflects off tiny ice crystals inside the cloud. But here's the cool part. Those ice crystals aren't just floating around randomly. They're moving because of shifts in the cloud's electric field. As the field changes, the ice crystals realign, and the light they reflect moves too. That's why the crown flash looks like it's flickering or waving. Crown flashes don't happen all the time. You need a thundercloud with the right conditions, lots of sunlight, ice crystals, and a strong electric field. If you ever spot one, consider yourself lucky. It's like nature showing off a rare light trick. We usually see ever-burning hills in sci-fi movies, but this one is real. Located in the Arctic region of Canada, the so-called Smoking Hills is an unmatched sight on our planet. And here, things get even a little science fiction-y, since some minerals that exist in these hills were only ever found in a few places on our planet and outside it, like on the surface of Mars. The ground of Smoking Hills has been releasing smoke for at least a couple hundred years, non-stop. Explorers thought the area was home to an active volcano, but that was not the case. As science explains, the soil in the area is formed by sulfur and coal, and when they're in contact with oxygen, they spontaneously ignite, releasing constant smoke. I just warn you, don't be getting any touristic ideas. The environment is extremely hostile to human life, as the smoke is toxic and its temperatures are dangerously high. In 1850, French scientist Auguste Mariette went to Egypt looking for manuscripts, but accidentally found a head of a sphinx sticking out of the dunes. He cleared the sand and figured out the sphinx was guiding the entrance to some underground construction. Several months later, he finally entered the Serapeum of Saqqara. Inside, he found an enormous granite sarcophagi with remnants of 64 bulls. Scientists are still amazed by the tech that the ancient Egyptians used to transport those enormous boxes. The Serapeum was built around the year 3000 before the Common Era. It was an underground tomb built to honor the sacred Apis bulls of ancient Egypt. It had a long hallway, almost 500 feet long, with giant stone rooms on both sides. Some of the sarcophagi weighed as much as 50 average cars, and all of them were made with super precision with exact 90-degree angles. These sarcophagi were beautifully decorated with hieroglyphs and carvings that told stories about the lives and importance of the Apis bulls. Now, there are 24 sarcophagi left. In ancient Egypt, Apis bulls were very special animals connected to the deity Ptah. They thought the bulls carried Ptah's spirit and wisdom, helped the pharaoh, and protected the Egyptians. Priests looked for special markings on young bulls to find Apis bulls. It could be a white triangle on its forehead, which symbolized divine light, a shape on its back like a vulture's wing, and a scarab shape under its tongue, which stood for rebirth. If a bull had these signs, they believed it was chosen by Ptah and treated it like royalty. The chosen bulls lived in a special temple in Memphis, the city where they worshipped Ptah. They received the best care and offerings from visitors who wanted their blessings. When an Apis bull passed away, it was treated with great honor and mummified. When Mariette entered the Serapeum, he noticed traces of rollers on the gallery's floor and found 2 wooden horizontal winches. Each had 8 levers. Later, other explorers saw double rails. The burial chambers were lower than the hallway floor. To get the boxes into place, workers filled the chambers with sand so the sarcophagi could be rolled in straight. Then they slowly removed the sand to gently lower the boxes into perfectly cut spaces in the bedrock. A carved stone sign found in the Serapeum said it took 28 days to move just one sarcophagus and its lid into its spot during the time of Ptolemy II. The extreme precision of the sarcophagi with 90-degree angles also has an explanation. Ancient Egyptians wrote texts, or rather, papyrus, on geometry a long time ago. It shows that they knew the approximate number pi and could calculate the volume of a pyramid with its top cut off. If they could figure out complicated math like that back then, it makes sense that they could also carve perfectly flat surfaces 500 years later. All this sounds pretty legit, but some people think certain things don't add up here. The size of boxes is way larger than the size of bulls, yet they buried pharaohs in tiny coffins that barely fit their bodies. The sarcophagi are made out of granite with crazy precision, and they could have just used limestone, which would have made things way easier. The transportation of the boxes seems pretty simple, but only in theory. If one person could pull about 440 pounds, then at least 250 people would be needed to pull just one box. The tunnels in the Serapeum are really narrow, only about 2 feet wider than the boxes themselves. There's no way hundreds of people could have squeezed into those tight spaces to pull the boxes. And even if they did, how would they turn the box in the cramped corridor, lower it into its niche, and place it perfectly in the middle? Somehow they did this 24 times, and every box is centered perfectly. Plus, the chambers were dusty and there were no signs of soot from lamps. This means they must have worked in almost complete darkness. The real use of the boxes could also be different. A long time ago, even before the Egyptian pharaohs ruled, the local people already knew how to use fermentation. It happens when tiny organisms called yeast eat certain ingredients like starch and turn them into gas and ethanol. So someone in ancient Egypt probably put food like barley, bread, and even meat inside a giant stone box, then closed it tight with a heavy lid. These stone boxes, carved from granite, were so precisely made that they were almost completely sealed, so nothing could escape from it. As the yeast inside the box started working, it created more and more CO2 gas. It built up pressure inside the box. The granite boxes were incredibly strong. They could handle more pressure than a car tire can hold. When granite was squeezed under such pressure, its crystals produced a tiny electric charge. This effect was possible because granite contains quartz, a material that reacts to pressure this way. The process also needed meat or animal parts, possibly to help the yeast grow better. Meat contains something called oleic acid, which yeast needs to keep growing and to survive the bad effects of the ethanol it produces. As the pressure inside the box kept growing, the combination of gases and electricity made these boxes not just ancient fridges, but powerful energy systems. Over time, the pressure inside got so strong that it could push the lid open and the gas would escape with a pop. But when people rediscovered the Serapeum in 1850, they found old drawings that showed piles of stones stacked on top of some of the box lids. So, someone long ago probably tried to make the lids even heavier by adding extra weight to make it harder for the gas pressure to push them open. This extra weight also meant the quartz crystals in the granite could keep creating more electricity under all that pressure. If someone opened one of these stone boxes thousands of years later, they would only find bones from bulls that were placed in the box. And that's exactly what Mariette discovered in the 1850s. They opened the Serapeum for visitors soon after the first excavations in the second half of the 19th century. Prince of Wales even had a luncheon with his guests in one of the sarcophagi. Sands and earthquakes made the site inaccessible for a while, but now you can visit it again and try to solve the mystery yourself. With new tech, we could have answers to many other historical mysteries soon. A team of scientists at Chicago's Field Museum of Natural History recently used a special CT scanner to learn more about ancient Egyptian mummies without unwrapping them. They gently rolled 26 mummies on custom carts out to the parking lot, where the scanner was waiting. It took thousands of detailed X-ray pictures of each mummy and their coffins. When all the pictures were put together, they created 3D images that showed what was inside, the skeletons, and some artifacts. The scientists hope these images will help them understand ancient Egyptian burial practices from over 3,000 years ago. Even though the scanning process only took 4 days, it might take 3 years to study all the data. But scientists were able to learn some personal details about the mummies. One of the most popular mummified individuals at the museum, Lady Chineta, was a woman who lived in ancient Egypt about 3,000 years ago. It looks like she passed away in her late 30s or early 40s. To make sure her body looked complete for the afterlife, embalmers put stuffing in her neck to keep it from collapsing. They also placed artificial eyes in her sockets, so she would have eyes in the next world. She was wrapped in fancy linen and placed in a beautifully decorated coffin. The scans revealed that it had been carefully crafted with a slit at the back, which embalmers used to fit the body. There were also some artistic details on the surface, like markings for her knees. It looks like her burial was on the scale of a high-end luxury car.
On December 5, 1952, a nauseating yellow-gray fog engulfed London, claiming 12,000 lives. This wasn't mere mist. It stank of rotting eggs and stretched 30 miles wide. Buses halted, planes were grounded, and ambulances were trapped. For 5 days, the city vanished in the stench and sludge. Streets slipped with a black ooze. Those who dared ventured out stumbled blindly, smudging their faces while birds crashed into buildings. With visibility zero, thieves ran rampant, and even indoor shows were canceled. The Great Smoke sent over 100,000 people to hospitals, leaving a grim legacy of demise and decay. The causes of this tragedy started long into the past. Something called pea soup fog became one of the symbols of London in the 19th century. Nature wasn't to blame for this fog. It was caused by people burning coal to heat their homes and run factories. In fact, London's air started getting smoky all the way back in the 13th century, when people began widely using coal. It got worse as the city grew bigger. By the 17th century, people were already complaining about the dirty air. King James I tried to prevent so much coal burning with new laws, but nothing really changed. As more factories popped up during the Industrial Revolution in the late 18th century, the problem blew out of proportion. The air was full of tiny particles that water clung to and formed dark, heavy clouds. This mix of smoke and fog became so bad, people called it smog. Yep, this word was invented in London in the early 20th century. The smog got so thick sometimes it could last for a whole week, and it made people ill. Some even passed away because of it. Even though the smog was harmful, people didn't want to stop using coal because it gave them jobs and kept their homes warm. So the problem lingered. By the 20th century, thick fogs were happening less frequently, finally, because factories started moving away from the city. But on that December day in 1952, an anticyclone appeared over London. This meant that the cold air near the ground got trapped under warmer air higher up, like a lid keeping everything underneath. Because of this, all the smoke from factories, cars, and home fireplaces couldn't float up and away like usual. Instead, it clung near the ground, mixed with water in the air, and produced an extremely thick, dirty fog. Plus, daylight in December is shorter, and it was really cold, so people had to use even more coal for heating and lighting than they normally did. All this led to a disaster. It was clear that sulfur particles from the burning coal made the fog yellow and smell like rotten eggs. But scientists couldn't figure out why and how these particles turned into sulfuric acid. Decades later, an international team of researchers recreated that scary fog in a lab. They used samples of air and atmospheric measurements from the fog in 2 large Chinese cities that have high levels of sulfur dioxide in the air, just like London during the Great Smoke. They learned that the thick, dirty air, called haze, doesn't form in the same way in London and in China. In London's fog, smoke from burning coal released 2 gases, sulfur dioxide and nitrogen dioxide. These gases mixed with water droplets in the fog, which made it harmless at first because the water diluted the harmful chemicals. But as the water evaporated and there was nothing to dilute the two dioxides, the fog became very acidic and hazardous to breathe, so it damaged people's lungs. In present-day China, things are a little different. A third chemical, ammonia, joins the mix. Now ammonia, which comes from farms and cars, helps balance out the acidity of the fog, so it's less harmful than London's deadly fog. But the scientists found that cutting down on nitrogen dioxide and ammonia could still help China reduce its air quality problems. They hope that their discovery will help both understand London's past fogs and give China ideas for making its air cleaner. It could also save the health of millions of people around the world who are now living in cities with bad air quality. After the terrible fog of 1952, everyone realized how serious London's air problem was. 4 years later, the British authorities created a law called the Clean Air Act to stop something like that from happening again. This law banned people from burning smoky fuels like coal in their homes or in factory furnaces in some parts of the city. To help people adjust, the authorities gave them money so that they could switch to cleaner heating options like oil, natural gas, or electricity. It took time for these changes to make a big difference, and sadly, another dangerous smog happened in 1962. But the Clean Air Act was a very important first step for protecting the environment and people's health. Almost a century before the Great Smoke, another smelly event happened to London, the Great Stink. Back then, people didn't have proper bathrooms or sewers, and all the waste from houses and factories went straight into the River Thames. When the weather got super hot in July and August, the water level in the river went down, and piles of waste, sometimes 6 feet, popped up on the muddy banks. The smell was so terrible that even Queen Victoria and Prince Albert had to cancel their relaxing boat ride on the river. The politicians working in the brand new Parliament buildings, which were right by the river, couldn't handle the smell either. The air inside was so terrible that they had to hold handkerchiefs over their noses to breathe. They even tried soaking the curtains in chloride of lime, hoping it would cover up the horrible odor. Many Londoners believe that the bad air, called miasma, caused horrible things like cholera, which had already taken the lives of lots of people. Engineer Joseph Bazalgette solved the problem as he built a new sewer system that would move all the waste away from the city. His sewer system was so well designed that it still works today, even though London has grown to over 8 million people. On the other side of the Atlantic, in the United States, there was also a day when you couldn't see your hand before your face, and it was impossible to breathe outside. But the reasons for this Black Sunday were very different from the Great Smoke of London. In 1931, it almost completely stopped raining in the southern Great Plains. This drought lasted for nearly 10 years. Without rain, the farms dried up and the soil turned to dust. Strong winds blew this dry dirt into the air and created huge dust storms. These storms, called black blizzards, made it hard to breathe and see anything. People tried to protect themselves by putting Vaseline in their noses, wearing masks, and sealing their homes, but the dust still made many of them sick. In 1934, things got even worse. It was the driest year in over 1,000 years. Temperatures went over 100 degrees for weeks, and the land became even drier. On April 14, 1935, after months of terrible weather, the sky finally looked clear, and there was barely any wind, which was rare for this area. People came outside as they were hoping that the worst was finally over. When Oklahoma minister announced that a few good rainstorms would make the land fertile again. But unfortunately, that morning, a cold wind from Canada met warm air in the Dakotas and started a massive dust storm. The storm grew to hundreds of miles wide and thousands of feet tall. A sunny day instantly became completely dark. Drivers had to hide in their cars, and other people went down into basements, found refuge in barns, fire stations, tornado shelters, and under their beds to stay safe. The storm didn't stop for hours and took at least 20 lives. Many people couldn't stop coughing, and one man went blind. The storm was so strong, it carried 300,000 tons of dirt across the country and even reached the East Coast. A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Uplifts wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Pun intentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happen not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves.
The ground suddenly starts shaking. Clouds of gas start forming in the sky, making it dark during broad daylight. Bits of the ground start swelling, lifting, and even collapsing. These are the telltale signs of a volcano that is bound to erupt. And this is what could easily happen again with Mount Spur. It's only about 75 miles from Anchorage, one of Alaska's busiest cities. More than half of the population of the northernmost state of the US live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario, a city being engulfed by lava. Spur may seem innocent compared to Vesuvio, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes.
Ah, Phoenix. This sizzling gem in the Sonoran Desert isn't just another American city. It's more like a giant oven where you can throw a party, as long as you don't forget the ice. Seriously, if you find yourself here in the summer, brace yourself for some serious heat. We're talking about temperatures that regularly pass 100 degrees. And in 2024, Phoenix hit 110 degrees 55 times during the summer, tying the record set just the year before. Now, I get it if you're not a fan of hot weather, but apparently a lot of people love living in a sauna. Phoenix ranks as the 5th largest city in the United States, and it is the capital and most populous city in Arizona, with 1.7 million residents as of 2024. And if we're talking about the metropolitan area, also known as the Valley of the Sun, the population is almost 5 million. Yet, good luck finding someone actually born here. Out of every 4 Phoenix residents, 3 were born somewhere else. Believe it or not, Phoenix wasn't always this bustling, crowded place. It became one. A few decades ago, it was just a sleepy little dot on the map. Back in the 1940s, the population was around 65,000. It wasn't even close to cracking the top 100 list of the largest U.S. cities. Now, at that time, Phoenix was mostly an agricultural hub, and its economy revolved around what they called the 5 C's: cotton, citrus, cattle, climate, and copper. But things really started to change in the 1950s thanks to one life-changing invention. Drumroll please? The air conditioner. Actually, it was the portable version that came out in 1945, created by an American inventor named Robert Sherman. Phoenix residents owe a lot to Robert for making life bearable during scorching summers. Before AC, people in Phoenix would literally move their beds outside and build sleeping porches. They'd protect that kind of outdoorsy space with light curtains or some kind of net to keep the dust and bugs out. Fun. Anyway, the point is that the air conditioner played a big part in making Phoenix an easier place to live. Since the 1940s, this city in Arizona has transformed from a dusty little town into a sprawling urban jungle, and it's still one of the top 10 fastest-growing metro areas in the U.S. The best part is, it looks like that won't change anytime soon, since this 519-square-mile metropolis is surrounded by rolling desert, with plenty of room to keep growing as far as the eye can see. So, who's dropping everything to move to Phoenix? Well, Californians are the city's biggest fans. According to a recent survey, a third of all new renters moving to Phoenix come from Los Angeles. Okay, that survey might not be the most reliable since it only applies to the source's clients, but it does line up with U.S. Census Bureau data from 2019, which says that 70,000 Californians moved to Arizona in the previous year. The connection between Phoenix and LA is so strong that some people even call Phoenix the next LA. You've got to give Phoenix credit for capitalizing on its proximity to Southern California. The city offers lower taxes, fewer regulations, and lower costs of living, which makes it a magnet for businesses, especially in high-tech and service industries. So, in the 90s, Phoenix was considered a non-stop generator of jobs. In the last few years, we've seen the number of jobs only go up, and the unemployment rate has dropped by nearly half, going from 6.3 in January 2014 to 3.4 in the same month in 2024. Now, when it comes to big city problems, you can't avoid talking about traffic. But here's another reason why Phoenix is a dream city. It doesn't even come close to the traffic nightmares you find in places like LA. Estimates show that people in Los Angeles waste about 119 hours a year just sitting in traffic. But in Phoenix, it's more like 61 hours. Huge difference, huh? And let's not even start talking about the money people waste just sitting in traffic. In LA, drivers burn through about $2,440 worth of gas per year. In Phoenix, they waste 25 gallons of fuel, which ends up costing about $952. Yeah, that's still a lot of cash, but compared to LA, come on, that's a steal. Phoenix being okay in terms of traffic might have a lot to do with how the city was designed. Just take a look at a map of Phoenix. You'll notice it looks like someone took a ruler and drew perfectly straight lines for the roads. That's because the city was laid out in a grid system. This setup makes it so much easier to get around, especially compared to cities full of confusing twists, U-turns, and one-way streets. It just simplifies things, whether you're a local or a tourist. Plus, Phoenix has nice wide streets. Most cities have one major road and a bunch of narrow streets that just can't handle heavy traffic. But Phoenix has wide roads everywhere. So, when the freeways get jammed, you can just hop onto a parallel street and still get to work without stressing out too much. When you look at all the job opportunities and the relatively smooth traffic, it's no wonder people are willing to put up with the heat and move to Phoenix. But don't get it twisted, the heat is no joke. It is really, really hot and sunny out there. We're talking about 300 days of sunshine on average, or about 85% daylight hours per year. But once again, Phoenix has made the best of it, and all that constant sunshine has turned Phoenix into one of the top solar energy cities in the country. Now, you may be wondering, a city in the middle of the desert with barely any rain, do they actually have enough water? Well, they do. Phoenix has its water situation pretty well sorted out, thanks to multiple sources. I mean, they don't rely on rain alone, which is a good thing because, desert life. Most of their water comes from way up north and east of the valley, where snow melts off the mountains and flows into giant reservoirs, storing it up for those dry years. But most of Phoenix's water comes from the Salt River Project, which brings water through canals and pipelines from the Salt and Verde rivers. Then there is the Central Arizona Project, which transports water all the way from the Colorado River. They even get a bit of water from underground wells. And Phoenix doesn't want to waste a drop, so they're smart about recycling, reusing treated water to keep parks green, and even recharging their groundwater. Since Phoenix is all about sunny skies nearly every day of the year, it's normal that people can get a little moody when it actually rains. But here's the thing. Phoenix always gets a surprise up its sleeve, even when it comes to bad weather. When it rains in the deserts, Locals get treated to this unique earthy smell. It's thanks to the creosote bush, a desert plant that releases an amazing fragrance when the rain hits it. People describe it as the smell of rain, and honestly, it's one of those fresh, clean scents that makes you forget you're in the desert for a second. And if you've never stopped to think about why Phoenix is called Phoenix, well, it's based on that famous legend of the bird that rises from the ashes. Now, after knowing all the special things about this city and its unique ability to turn challenges into advantages, we can say the name couldn't have been better chosen. Recently, scientists made an astonishing discovery that might solve Stonehenge's mystery. They found something hidden deep within the DNA of Stonehenge's sarsen rocks, the huge monolithic ones, and it might reveal why our Neolithic ancestors designed and built this thing in the first place. Over the years, scientists have been scratching their heads trying to figure out where the huge sarsen rocks came from. For years, they believed they came from a quarry just 15 miles away from the site, known as Marlborough Downs. At this site, they found similar minerals to the ones that make up the sarsen rocks. But it turned out there was more to this story than they thought. The understanding of how Stonehenge was built is always changing. Scientists need to really travel back in time to uncover its mysteries. Where did the rocks come from? How were they carried? Why was the site built? You see, the Stonehenge site, located at Salisbury Plain in England, is made up of two main types of stone. There are the super heavy sarsens and the lighter and smaller bluestones. The sarsens each weigh about 25 tons. That's as much as 3 African elephants stacked together. The heaviest sarsen stone, called the heel stone, weighs 30 tons all by itself. Together, the sarsens make that iconic outer ring circle. Inside that circle, that's where you'll find the bluestones. The naming might seem a bit misleading since they're not really blue. They have a bluish tinge to them when they are freshly broken, hence the name. These smaller rocks probably came from the Preseli Hills in southwest Wales, which is about 150 miles away from Stonehenge. They're a bit lighter than the sarsens, but still pretty heavy. The altar stone, which is classified as a bluestone, is the heaviest one, weighing around 6 tons. Its original location still isn't known for sure. To figure out where a rock came from, scientists first have to study their composition. This is like checking the rock's DNA. Then they cross-reference the structure of the rock with minerals in the soil to see if it's a match. Most of the sarsens we see around southern England are actually made of a type of sandstone known as silcrete. Think of silcrete as sand that's been hardened by underground water processes over millions of years. This process mostly happened during a period called the Paleogene, about 65 to 23 million years ago. These sarsen rocks didn't form in one big slab, but in patches, like nature leaving little rock gardens all over the place. Scientists reason the sarsens spread out randomly, forming in isolated pockets. Over time, many were buried under layers of clay and chalk, which helped preserve them. When ancient builders were on the lookout for materials, these sarsens must have looked perfect for something impressive like Stonehenge. Actually, sarsens have been used in everything, from Roman villas to medieval churches, and even in things like road curbs and old field walls. One could say these rocks were the it material for ancient builders, and continue to be popular even into more modern times. This fact made scientists start wondering that maybe not all sarsen stones that were used to build Stonehenge came from the same place. They've identified sarsen sites all over the UK, in places such as Oxfordshire and Kent. After hundreds of years of studying the sarsens, geologists finally had the right type of technology to determine the origin of the stones. Now, I wish I could tell you that it was some undisclosed location very far away from the site. But, as it turned out, the sarsens were originally from Westwoods, the forest near Stonehenge. A new factor came into play when excavations uncovered empty stone holes. showing that at least 6 bluestone pillars were removed from a Pressley Hills site called Wan Main in prehistory. They had a stone circle over there, and it's believed that some of Stonehenge's rocks were recycled rocks from this more ancient circle. If this is true, it might be that Stonehenge is part of a much larger landscape of ancient sites. If this is the case, then Stonehenge is just the cherry on top of a much larger scale project. Think of it as the sacred centerpiece of an entire landscape of monuments, mounds, stone circles, and things. This is why scientists want to find out where the rocks came from so badly. It could lead to why and how Stonehenge was built. Now, Stonehenge didn't just pop up overnight. It was built in several stages over hundreds of years. It's likely that it wasn't a single unified vision, but more like a big community project that evolved over time. With each generation, the builders brought in their own ideas, creating a stone structure that would last for ages. The first stage was around 3100 BCE. That's when people dug out a circular ditch and likely set up some bluestones as sort of a starter ring. Later, they added the Sarsens and even topped some of them with horizontal stones to form those famous arches you see today, also known as the trilithons. These ancient builders had some challenges on their hands. How would they move the rocks? There's an old theory known as the ice road that suggests that the rocks were moved by natural icy pathways that formed during the winter. This way, they could slide the rocks down all the way to Stonehenge. But hey, if we're talking about a distance of over 100 miles, that's not too realistic. Anyways, this theory was debunked because it was warmer back then than it is today. There's also the river theory, which suggests that the rocks were floated along the river from the quarry to the site. But if we're talking about Sarsen rocks, they're too heavy to float. So there goes that theory. What we're saying is, no one knows how the rocks were moved. Another interesting science tidbit came from all the research done in Stonehenge. A recent laser survey of the stones revealed the different stone working methods used, and has shown that some of the parts of the monument were more carefully finished than others. In particular, the northeast side and the inner faces of the central trilithons were finely dressed. FYI, a trilithon is one of Stonehenge's most famous shapes. It's when two huge monoliths receive a third one on top of them, connecting the two together. This fancy word is simply Greek for having 3 stones. But anyways, the bigger question, and the reason Stonehenge is so famous, is why it was built in the first place. Theories are all over the place, and some sound like they're straight out of a sci-fi show. So here's a rundown of the most popular ideas. There's, of course, the solar calendar theory. This one supposes that the stones are aligned with the movements of the sun, especially during the summer and winter solstices. During the summer solstice, the sun rises to the left of the heel stone, that's the lone stone outside the main circle, lighting up the entire monument. Some say it's the ancient version of a calendar, marking the year's longest and shortest days. Some archaeologists think Stonehenge might have been an ancient healing center. Pieces of bluestone have been found chipped away, possibly by people who believe they had healing powers. The theory goes that people traveled from all over to come to Stonehenge in hopes of a cure for whatever was ailing them. There's also some speculation that Stonehenge was the place to be. Think of it as an ancient gathering spot. Some evidence suggests that communities from distant areas traveled to Stonehenge for gatherings, feasts, and ceremonies. Studies of bones found near the site show they came from all over Britain, making it a sort of prehistoric meetup location.
Lake Michigan is one of the largest and most mysterious freshwater lakes in the United States. And now, deep inside it, scientists have stumbled upon something unexplainable. Vast, round craters scattered all across the lake's floor. It all started in 2022. A team of researchers wanted to map the lake's bottom and look for some shipwrecks. At first, they were sure it's going to be just some typical rocky terrain or sandy patches. But what they saw on their sonar screens stopped them cold. Strange circular shapes that looked almost too perfect to be natural. They were hiding about 500 feet beneath the surface, in places where the water turns dark and impenetrable. Those guys are huge, ranging from 300 to 600 feet wide. They also plunge nearly 40 feet deep. And there are dozens of them, neatly arranged like some footprints. But the team had no idea what these things were. Then, in August 2024, the mystery only deepened. Using a remotely operated vehicle, they got a closer look at these formations. There were about 40 of them. No one had ever seen anything quite like this before in the Great Lakes. What could have created those craters? Could they be ancient? Perhaps remnants of some geological event lost to time? If that's the case, it's weird how long these holes have likely been sitting there, undisturbed. Theories started popping up. One possibility was that they could be sinkholes, or dolines. Those are basically holes that suddenly appear in the ground when the surface layer collapses. The rock beneath the surface, often made of limestone, gets slowly dissolved by water over time, creating voids underground. When the surface of those voids can no longer hold its own weight, it caves in, and this forms a hole. Think of it like when you poke a straw through the lid of a drink. Sinkholes can be small dips or huge, spanning up to 2,000 feet. They can happen gradually or all at once. Sometimes they can swallow entire cars or even buildings. And Lake Michigan sits on limestone bedrock. It erodes pretty easily when water flows through it. Sinkholes like these have already been found in Lake Huron, and they look kinda similar. But there are some plot holes, no pun intended, with this theory. For example, it's wild how they all would be so huge. It's also weird and pretty rare for sinkholes to occur in a lake bed. They also kinda resemble a straight pattern. They seem to extend generally southward, forming a loose line, which is pretty weird. If these are sinkholes, then they're definitely not playing the usual geological rules. Though it might be some new, unusual process at play beneath the lake's surface that we haven't discovered yet. There's another theory though: glaciers. Glaciers are wild rivers of ice. They covered much of the Earth during the last ice age, and they're incredibly powerful. While they might move slowly, sometimes only a few inches per day, they have such immense weight that they can reshape entire landscapes over thousands of years. Glaciers can grind and scoop the land beneath them. They're basically like colossal bulldozers. Their weight, combined with the slow but steady movement, grounds down everything beneath them: rocks, soil, even bedrock. This can create deep gouges in the Earth's surface, called glacial troughs. During the last ice age, there were lots of glaciers all over the northern US, including the Great Lakes region. If they moved across what is now Lake Michigan, they could have carved out these deep holes. Glaciers often move in a pretty straight path. As they move, they cause terrain to erode, but the resulting erosion varies based on terrain. Sometimes there are places where the bedrock is softer or fractured, and these places are more easily carved and crushed by the glacier. That could explain why some holes could be bigger and deeper than others. Harder bedrock is less affected. But usually this leads to rounded, crescent-shaped depressions known as chatter marks. Those marks are more like grooves rather than circular, big craters like those in Lake Michigan. Once the glaciers melted, the Great Lakes themselves formed. If the craters were formed by them, they may have filled with water, becoming part of the Michigan Lake. Though this theory is more like a speculation, so we need more evidence. But there's another layer to this mystery. The craters are not just curious geological formations. They actually may hold valuable clues about early life on Earth. Parts of Lake Michigan, especially dark ones, are relatively low in oxygen. It's like a lighter version of deep ocean environments that often have very little of this element. For example, hydrothermal vents deep in the ocean, underwater openings in the Earth's crust with some hot, mineral-rich water that are often very low in oxygen. But some organisms love places like these. For example, opossum shrimp. Teeny tiny shrimp-like creatures that love cold, deep waters. They get their name because they have a pouch to carry their young until they're ready to be on their own, like an opossum. Or deep-water sculpin fish, small bottom-dwelling fish that also enjoys cold lakes. They're well adapted to living in dark waters and usually stay close to the lakebed. And weird organisms like invasive quagga mussels, which kinda look like shells. These are small freshwater mussels that have spread there to the Great Lakes. They attach themselves to hard surfaces and can cause problems for ecosystems by competing with native species for food and space. All these guys could be in Lake Michigan, and even more. There might be microbes or even bacteria that are specially adapted to these harsh conditions, just like it was in Lake Huron. There's only a handful of creatures that could survive deep within these craters, and studying them could give us insight into how life once flourished in Earth's ancient, oxygen-poor oceans. That's because it's in places similar to these, where some of the earliest life forms thrived. Early Earth had an atmosphere with little oxygen, although it was much more hot, and ancient microbes adapted to this. The Great Lakes, especially Lake Michigan, have always had a bit of a ghostly reputation. Like even this mission was organized to study the shipwrecks. There were about 6,000 of them in the Great Lakes. Many of these wrecks are still sitting on the lake beds, preserved by the cold, fresh waters. And shipwrecks aren't the only strange things tied to the Great Lakes. Over the years, there have been stories of unexplained disappearances. Boats and even planes have vanished without a trace. The lakes, often calm on the surface, can suddenly turn dangerous with unpredictable storms and massive waves, leading to these mysterious events. Not even mentioning all the creepy stuff people notice there over the centuries, such as ghostly lights above water or bizarre weather patterns like eerie, sudden fogs that seem to appear out of nowhere. In 2007, they even discovered some prehistoric structure that looks like Stonehenge there. Well, it was way smaller, but still. It lay about 40 feet below the surface in the heart of Grand Traverse Bay, and it's speculated to be about 9,000 years old, way older than Stonehenge. Looks like this is a print of those who lived in the area thousands of years ago. These massive stones are arranged in a careful, winding pattern stretching over a mile. They range in size from basketballs to compact cars. But one, in particular, stands out. A boulder 3.5 to 4 feet tall, 5 feet wide. It's etched with the image of a mastodon, a creature that roamed the Earth about 11,000 years ago before it went extinct. It probably sank there during the end of the last ice age we mentioned. This period had reshaped the region. This place is underwater now, but back in the day, it was still dry land. So the stones were probably created by people who lived there, though we're not sure why. Were they used as hunting blinds? Or was it some sort of an ancient calendar? Who knows? Only about 15% of the Great Lakes floors have been explored. Now, scientists are gearing up for a deeper dive into this mystery, both literally and figuratively. They want to analyze the lake beds surrounding the craters, hoping that maybe something in the environment around them might have caused them to appear. They have initiatives like Lakebed 2030. These missions should map the entire underwater landscape. This would help us learn tons of interesting stuff about Lake Michigan and our planet's past. Who knows what other secrets these dark waters hide?
It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nadir crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nadir crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nadir asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA's keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700. But still, it's a reminder that Earth is always in the cosmic firing line.
When you mention your plans to travel to Tristan da Cunha, the chances are your friends won't even know where this remote island is located. No wonder. Tristan da Cunha is considered the most remote inhabited archipelago in the world, with the nearest populated land, St. Helena, around 1,500 miles away. There are only 229 people living on Tristan da Cunha now. In such a close-knit community, everyone is someone's cousin, uncle, or maybe just a friend, but everyone knows each other for sure. There are as few as 10 last names on the island, representing just 10 families. Getting there is quite an adventure. There are no airports on the island, which means your journey will be primarily by sea. Typically, it requires a days-long voyage from South Africa. Only 3 ships regularly service the island, with fewer than a dozen trips each year. Some cruise lines may include it in their itineraries, but travel arrangements must be made well in advance, due to limited berths available on the ship from Cape Town. And you'll also need landing permission. While Tristan doesn't have traditional hotels, there are several guest houses, and you might also have the chance to stay with a local family. They will provide you with a place to sleep, 3 meals a day, and laundry services. 88% of what you pay goes directly to the island family, and only 12% is tax. By the way, the accommodation is surprisingly affordable. It was around £65 for a full board in 2024. Yep, they do use sterling, being a part of overseas British territory. But there's also this local currency called St. Helena Pound, used at parity with sterlings. By the way, it's only been around 80 years since the island started using actual money. In 1942, the naval station began paying cash wages, and it helped Tristan Islanders to move from a barter economy to a cash-based system, and allowed them the novelty of making their first cash purchases. Just a heads up, pack everything you might need before you go, as you definitely won't come across Walmart there. I mean, don't get me wrong, there's a supermarket and all, but it's just not the way you're used to, with endless shelves displaying endless oversized mayo jars. Tristan's Island store, often referred to as the supermarket, lacks plate glass windows and flashy advertisements, and let's be honest, it looks like an abandoned barn from the outside. Still, it plays a crucial role in providing essential goods to complement locally produced foods and woolens. If a resident wants to buy something, they must place orders months in advance for items that arrive with incoming ships. The store operates Monday through Friday. Today, the islanders continue to cultivate their own crops and raise livestock. The supermarket has become a vital source for other essentials like flour, sugar, and a variety of groceries including frozen bread and products typical of the UK or South African supermarkets. And even though the island's economy relies heavily on fishing, especially rock lobsters, islanders are largely self-sufficient. Let's move to another destination that's super hard to reach, but this time it's a level up in difficulty. I'm talking about the notorious Hypoxia City, the place with the smallest amount of oxygen on the planet. Sure thing, it's a nickname. The real name is La Rinconada. This place is located in Peru. Getting there means climbing over 16,000 feet up into the mountains. And what did you expect from the highest city on Earth? Despite its hard-to-reach location, it houses way more people than Tristan da Cunha, between 30,000 and 50,000. And while the island in the middle of nowhere looks idyllic, the Peruvian city of La Rinconada has very different looks. The urban layout features predominantly low-rise residences, where essential services are limited. La Rinconada is without a reliable supply of running water and lacks a sewage system. The community does not have a waste collection service, which forces residents to either burn or bury their garbage. Moreover, up until the early 2000s, La Rinconada did not have access to electricity. Most things, including the most essential foods, must be brought here from outside. Despite originally being a miner city, right now it has a wider range of activities to make your living. Some people are busy with trading, food, clothes, you name it. Others provide services, and some people even open public restrooms. Architectural-wise, La Rinconada has very little to offer. The pattern is quite predictable. Huts made from corrugated metal that are unstable and rusting. The choice of materials is dictated by practicality. These metal sheets are the lightest and easiest for miners to transport to the glacier. Unfortunately, the homes lack proper insulation, leaving residents shivering in the cold even though they have access to wool from local sheep, which is an excellent insulator. Sturdier rock homes exist but are rare, typically inhabited by wealthier miners. While the architecture might not be particularly captivating, the vistas certainly are. In nearly every spot in La Rinconada, a glance upward reveals La Bella Durmiente, or Sleeping Beauty, a massive glacier towering over the town. Getting to La Rinconada is very hard. First, you'll need to fly into Alejandro Velasco Astete International Airport in Cusco, Peru. Once you're in Cusco, you can catch a train or a bus to Puno, which is right by Lake Titicaca. Here's where it gets a bit tricky. The only way to really get up to La Rinconada is by hitchhiking or finding a ride into the mountains. There might be some buses, but they don't run on a set schedule. If you're up for it, you can rent a car, but be warned, the roads can be pretty rough and tricky to navigate. So a little extra caution goes a long way on this adventure. Unlike Tristan da Cunha, where they adopted cashback in the 1940s, La Rinconada doesn't rely much on it. The economy of this place is based mainly on gold mines. The mines are unguarded, unregulated, and often dangerous. Miners work for 30 days under a cachorreo system, where on the 31st day, they're allowed to take as much ore from the mine as they can carry as a form of payment. La Rinconada has no bank, but it has many storefront fund transfer agencies, which miners use to wire money to their families. Still, they never know how much they're gonna send. Our next destination is Svalbard, a place that might seem unwelcoming due to its climate, But locals embrace everyone with open arms. No visa is required if you want to visit or even work there. Located near the top of the world, Svalbard offers a unique and remote charm. The capital, Longyearbyen, is home to a fascinatingly diverse community, with over 50 nationalities represented among its 2,400 residents. You might even spot a polar bear wandering into town on occasion. The living space is compact. There's just one grocery store, and the streets are numbered instead of named, adding to the town's distinctive feel. Longyearbyen also boasts a university center with around 300 students. Interestingly, every student must learn to use firearms for safety in the surrounding wilderness. Originally, it was founded as a mining town, just like La Riconada, but the focus has shifted mainly to tourism. However, a quirky tradition remains from its mining days. Visitors and residents alike take off their shoes when entering hotels and restaurants, a practice born out of the need to keep coal dust at bay. The last destination for today is Palmerston Island, a remote coral atoll in the Cook Islands, located about 290 miles northwest of Rarotonga. Famous traveler James Cook visited it on June 16, 1774, and the place was uninhabited at the time, despite ancient graves found there. Today, the island supports a small population of just 25 residents, primarily descendants of 19th century English sailor William Marsters. Marsters arrived in 1863 with 2 Polynesian wives and later added a third. He fathered 23 children. Fishing is the mainstay of the local economy, resembling subsistence living due to the island's isolation. Modern amenities and communication services are available. Although there's no airport, cargo ships visit periodically. This sleek, state-of-the-art submarine named Ran was sent to explore the depths of Antarctica. But as soon as it discovered something, it mysteriously disappeared. So, what happened? It all started when scientists wanted to explore one of the most remote and mysterious places on Earth, the Dodson Ice Shelf in West Antarctica. This ice shelf, silent giant, stretches 30 miles wide. That's almost the length of New York City. It stands between 2 icy promontories, the Martin and Bear Peninsulas, and it hides an entire world of geological mysteries. If you think that Antarctica is nothing but a desert of super thick snow and ice, you're wrong. There are entire landscapes hidden deep down there. The underside of the Dodson Ice Shelf is a rugged, dynamic terrain shaped by the slow, relentless forces of nature. There are towering ice formations, deep troughs, and bizarre structures stretching for hundreds of feet. Scientists are super curious about it, but as you can imagine, this landscape isn't easy to explore at all. To find out more, we have to scan the area with satellites or try drilling through the snow, trying to collect the big picture, piece by piece. But these methods only gave us vague hints. The real breakthrough happened when scientists came up with the idea to let the submarines explore it. Autonomous submersibles could swoop deep into the icy waters beneath the Dodson Ice Shelf and tell us what's up down there. These robotic explorers have fantastic advanced sonar systems. It's that thing that bats or dolphins do. They can use sound to see the world. Basically, they send out sound waves underwater, and when those waves hit something like the ice shelf above or the seafloor below, they bounce back to the system. Animals feel how long it took for the sound waves to return and how they changed. And this helped them understand what's located where. For example, clicks that dolphins send out tell them where the fish are. We copied this crazy evolutionary trick and adapted it to our underwater exploration. Only our version is much cooler, with a higher level of precision, so we created detailed maps of the environment. The Rand submarine was one of those robotic explorers. It was named after the Norse deity of the sea. Ran had been meticulously programmed to navigate a treacherous landscape of Antarctica. But even with all this training, its journey led to an unexpected and eerie end. In 2019, Ran was sent to explore the depths beneath the Dodson Ice Shelf. It was a hero, the first one to go on a mission like this. The team said it was like seeing the other side of the moon. For 27 straight days, it worked tirelessly, It traveled over 620 miles beneath the thick ice. That's like a journey from Paris to Berlin. RAN went further and deeper than anyone could have imagined. At one point, it reached over 10 miles into the glacier's belly, and what it discovered down there was astonishing. Scientists thought there would be some smooth, uniform ice surfaces, but RAN revealed an underside marked by huge cracks, ridges. There were formations that looked like sand dunes, frozen in time. And finally, it found some mysterious swirling and teardrop-shaped patterns. They all looked more like art than geology. This actually tells the story of ice shelves and the ocean around it. Warm water sneaks in under the ice and melts it from below. Sometimes it smooths the ice out, but other times it carves out these weird, uneven shapes that look like patterns and drawings. And some of these shapes are huge, over 1,300 feet long. That's about 3.5 football fields. The reason why they look like swirling doodles is because the Earth spins. It makes the water turn in special ways, bending the shapes and drawing these spirals. It's called the Coriolis effect. Imagine you were on a merry-go-round and tried to throw something like a ball. It would go in a curve, not a straight line. Same thing happens with the water on Earth. Later, scientists found similar patterns in other Antarctic ice shelves, though they weren't as epic as the ones under Dodson. But RAN also discovered something horrifying. Turns out that these warm waters, aside from being great artists, are also a huge danger. The Dodson ice shelf isn't just hanging out serenely on the sea. It's part of a very delicate system and acts as a protective barrier that holds back huge glaciers in West Antarctica. The ice shelf is floating on the ocean, but it's still connected to the land. As warm water sneaks underneath it and the ice melts, the Dodson can't hold on to the land as tightly anymore. The protective barrier starts to weaken, and this lets the glaciers behind it move faster into the ocean. When those glaciers flow into the sea, they add more water, which could cause sea levels to rise, eventually changing our coastlines. RAN stumbled upon huge pockets where the ice was melting at alarming rates, all due to powerful underwater currents. It was like seeing a ticking clock on the glacier. The stakes were high, but luckily the submarine was ready. This time, it managed to return. And then, it worked for 5 more years, helping scientists with tons of useful data. The missions were daunting. There could be periods where RAN slipped into the pitch-black cavity beneath the glaciers, spending 24 hours without communication. But it was mapping every peak and every valley. It gained experience from over 40 missions below ice. Then, in early 2024, RAN went on a mission to the Thwaites Glacier. The mission was bold from the start. This place is also ominously referred to as the Doomsday Glacier. It's called that because it's slowly melting and has the potential to raise sea levels worldwide if it collapses, causing catastrophes everywhere. That's why RAN was dispatched to explore its underbelly, a place that had never been mapped so intricately before. The idea was to uncover the glacier's secrets, study how rapidly it was melting and why. This was RAN's second time exploring Thwaites. During the previous visit, it became the first sub to ever map the glacier's underside. RAN was exploring the depths from 650 feet to 1,650 feet. It sent a lot of data about how the Doomsday Glacier was slowly melting due to warm ocean currents. But while venturing into these icy depths, something went wrong. Out of nowhere, RAN vanished. Without warning, without a trace. One moment it was sending back crucial data, and the next it had slipped into the abyss. No distress signals, no final transmission, and it didn't return to the point it was supposed to. People sent extensive searches, helicopters soared overhead, drones buzzed through the frozen skies, but no sign of the submersible emerged from the glacier's grasp. After a while, RAN's batteries would certainly run away. So at this point, it had definitely been swallowed by the abyss beneath 1,500 feet of ice. That was a huge and sad loss for the scientific team. The scientists at the University of Gothenburg are now looking to replace RAN and continue their important research under Thwaites. To this day, Scientists have no idea what happened to it. Some say it may have been trapped in the ice. Others believe it was pulled away by an unseen current. It also might have collided with something unexpected. Whatever the truth is, its disappearance has left scientists stunned, and it looks like the ice shelf will hold on to its secrets a little longer. At least we gained a treasure trove of knowledge from Rand's journey. Scientists keep exploring Antarctica, looking for history that hides under the snow. For example, they discovered that around 90 million years ago, a lush temperate rainforest thrived near the South Pole. They revealed an ancient world far warmer than they ever imagined. Deep in Antarctica, they unearthed fossilized roots, pollen, and spores preserved in the soil. All this shows that there was a swampy rainforest that flourished despite months of polar darkness. All these discoveries changed our understanding of Earth's climate, both in the past and the future.
You know, those fluffy cumulus clouds you see in the sky weigh as much as a Boeing 747 or 100 elephants. Hey, if you don't believe me, let's do the math. Scientists figured out that the density of water inside a cumulus cloud is around 0.5 gram per cubic meter. Now, clouds come in all sizes, but an average cloud of this type is shaped somewhat like a cube and has a volume of 1 billion cubic meters. When you multiply it by density, you get an impressive result of slightly over 1 million pounds. And in case you were wondering, this giant stays afloat because its density is lower than that of the air surrounding it. Giraffes are 30 times more likely to get struck by lightning than you are. There were 5 official fatal cases involving giraffes and lightning between 1996 and 2010. But since their population worldwide is just around 140,000 during that period, the fatality rate is rather high per 1,000 of giraffes per year. Lightning bolts love tall objects, so giraffes are unfortunately an easy hit. But scientists think they might have learned to deal with it and seek shelter during a thunderstorm or move quickly to thickly vegetated areas. The oldest animals on Earth are glass sponges. They can live up to 15,000 years. Scientists found the oldest glass sponge in the Ross Sea, a part of Antarctica. In another part of the world, the East China Sea, scientists found the skeleton of a glass sponge that lived for about 11,000 years. These sponges might have been around during the last ice age. They lived their whole lives stuck to hard surfaces, filtering water to snack on bacteria and plankton. So, our Earth is spinning more slowly now, which means our days are getting a bit longer over time. Long ago, I wasn't around then, a day on Earth was only about 19 hours, but then it grew to 24, mostly because the moon's gravity pulls on Earth and slows it down. Different extreme things go on in nature that can change the speed of Earth's spin in the short term. An earthquake in Chile in 2010 may have made our day a little bit shorter, according to scientists. But since 2020, the days have been getting longer again. Now, scientists still can't decide if water is actually wet or not. Some of them say water isn't wet itself, but it can make other things wet when it sticks to them. Others think water is wet because it's a liquid and has moisture. Water can feel wet because it cools your skin as it evaporates. How wet something is depends on 2 forces: cohesive forces that keep water droplets together and adhesive forces that make water stick to things. Water doesn't stick well to waterproof fabrics, and they stay dry because cohesive forces are stronger in that case. Guess what? There is no map of the world that would be 100% accurate unless it's life-size. Our planet is round and paper is flat. Duh! Back in the 16th century, Gerardus Mercator designed a cylindrical map projection that is still used and named after him. This concept is good for navigation because the north is always up, but the top and bottom parts get stretched out. So Greenland looks 14 times larger than it really is, and Alaska is the size of Brazil. Around 4 billion years ago, Earth's atmosphere was very different from what we know and love. But volcanoes saved the day. Tons of them were erupting all over the place, spewing out carbon dioxide. This gas filled the sky and made up most of the atmosphere. Tiny early plants used that carbon dioxide to grow by photosynthesis and give out oxygen. One of the theories says that the steam from all the volcanoes cooled down and turned into water and gave us the oceans. It took about 2 billion years for enough oxygen to fill the air so that animals could live and breathe here. Now, if for some reason you ever decided to stack all the world's germs and bacteria on top of each other, they would stretch for 10 billion light-years. But you wouldn't even see this thread, because it would be about 75 times thinner than a human hair. If you wrap this long line of bacteria around our galaxy, the Milky Way, it would circle around it more than 20,000 times. Ooh, my brain! It turns out there's rust on the moon, and it may have traveled all the way from Earth to get there. Now, rust usually needs oxygen and water to form, and the moon has almost none of either. But when this celestial body passes through a part of space called Earth's magnetotail, oxygen from Earth can reach it with solar winds. This oxygen may have combined with tiny amounts of water and iron on the moon's surface to create rust. Now, even a tiny asteroid can knock our planet out of its orbit. But don't worry, you probably won't even notice any difference. The effect of an impact will depend on many things, like how strong the space rock is, how fast it's going, and what kind of ground it hits. Most of the time, when space rocks hit Earth, they break apart or turn to gas before they reach the ground. But big ones, like the one that wiped out the dinosaurs, can cause huge problems, like big waves, earthquakes, and even change the weather. The Earth isn't solid like a rock on the inside, but more like squishy clay because of the very high heat and pressure deep underground. This squishiness allows the mantle to move very slowly over millions of years, and that's why we get earthquakes, volcanic eruptions, and the shifting of continents. During the last ice age, huge heavy glaciers sat on top of Earth's surface, pressing down on the squishy mantle underneath. This made the mantle sink a bit. When the ice melted, the mantle started pushing back up and the land began to rise again. Even today, in places like Canada, Greenland, and Scandinavia, the land is still rising because of this. Our planet is covered with cosmic dust. About 5,000 tons of it reach the surface of Earth every year. This interstellar substance is smaller than a grain of sand and often even thinner than a human hair. Scientists go all the way to the middle of Antarctica, where it barely snows, and the snow is super clean to spot those particles. Most of this dust comes from comets. If you're an introvert, Greenland is the ideal place for you. It is the least densely populated area in the world, with only 0.1 person per square mile. Wow, I've never actually seen a tenth of a person. Anyway, most of Greenland is covered in ice, so people live mainly along the west coast. Oh, and by the way, it's been inhabited for over 4,500 years, so it must not be that bad after all. Guess what? The ground you walk on is actually recycled. First, hot melted rock from magma comes to the surface and cools down to become solid rock. Then, thanks to tectonic forces, the rock gets pushed up to the surface. Over time, wind, rain, and other forces break pieces of the rock off. They get carried away and eventually settle down in layers. These layers get squished together, forming sedimentary rocks, like sandstone. Sometimes, if these sedimentary rocks get pushed deep under the Earth's surface, the heat and pressure cook them into a new type of rock called metamorphic rock. A long time ago, life on Earth might have been purple instead of green. A molecular biologist from the University of Maryland thinks that the very first microbes used a special molecule to capture sunlight that made them look purple. Today, plants are green because they use chlorophyll to absorb sunlight and turn it into energy. But before chlorophyll existed, retinal molecules did the same job. It soaked up green light from the sun and reflected red and purple light, which made the microbes look violet and like little tiny grapes. Really. Hey, look at this rock. At first sight, it looks like a regular boring rock, the likes of which you can see when walking along the beach. Its color doesn't stand out, and its weight is pretty regular, around 4 pounds. But everything changes when you learn that this rock was born on Mars, traveled all the way to Earth, and ended up in Antarctica. Ah, now the story sounds much more fascinating. So let's find out the details. Researcher Roberta Score, who worked on the ANSMET project, which stands for Antarctic Search for Meteorites, of the Denver Antarctic Program, found this meteorite in 1984. If you want to decipher the name of the space traveler, I can help you. It comes from the place where the scientists spotted it, the Allen Hills of Antarctica, hence ALH. And then we've got the year of the discovery and the number of the sample. If you think that Roberta picked up the rock and exclaimed something like, "Woohoo, I'm holding a chunk of Mars," I'll have to disappoint you. At the very beginning, it was totally unclear where the meteorite came from. And one thing confused researchers even more. The meteor was very different from other meteorite groups found on our planet. Okay, but then how did they finally figure out it was a visitor from Mars? All thanks to traces of gas similar to those that make up the atmosphere of the red planet. We learned about its composition thanks to the brave Viking lander that carried out the necessary analysis in situ in 1976. Anyway, back to our rocky discovery. It's actually very special, and not only because the rock arrived from far, far away. Among those several thousand meteorites found on Earth, just around 100 have likely come from Mars. And even so, our guy is different from them and seems to be part of a separate group. So let's go into the past and follow the life story of this cosmic traveler. It most likely formed around 4 billion years ago on its home red planet. One day, which wasn't very different from others, turned out to be life-changing for this peaceful rock. A meteorite impact catapulted into space, and it started its own journey as a small asteroid. At that time, it was way larger than at the moment of discovery on Earth. At one point, ALH got close to Earth and, who knows, probably decided to explore something. That's how, 13,000 years ago, it ended its space journey by colliding with our planet. At the moment, this Martian fragment is the oldest we've got. But at first, it wasn't all that popular. Only in 1996 did it become way more famous after a groundbreaking discovery. You see, some NASA researchers started wondering, well, the fragment is obviously very old, but then, could it have recorded any traces of life that could have been thriving on Mars at the time ALH formed on the red planet? And guess what? Those scientists turned out to be right. They detected traces of very fine magnetite particles. Those were completely similar in structure and chemical composition to the particles we have on Earth. They're called magnetofossils, and magnetotactic bacteria produce them. So it might mean that, at one point, there were some forms of life on Mars. In April 2020, scientists from the Japanese Space Agency made another discovery. They detected nitrogen containing organic material of Martian origin in our meteorite. So, who knows what new astounding secrets further examination of the meteorite might reveal? At the moment, though, all you can do is travel to Antarctica and find more of them. The thing is, this place is great for meteorite hunting. Surprisingly, we have found nearly 50,000 meteorites in Antarctica, and hundreds of thousands are still waiting to be discovered. Each of these space rocks can tell us a story of the evolution of the solar system. For example, the very first lunar rock found on the icy deserted continent proved that chunks of space objects larger than asteroids can also end up on Earth. So, let's say you got inspired and decided to go meteorite hunting all the way to Antarctica. Well, get ready for some serious challenges. Despite their potential abundance, finding space rocks isn't as easy as it might seem. You'll have to visit remote areas, and there's still no guarantee that you'll be able to spot a meteorite. And that's actually a huge problem. Meteorites are vanishing from sight. Currently, scientists find about 1,000 meteorites in Antarctica each year. But according to a new study, about 5,000 more get hidden out of sight every year. The culprit is warming temperatures. Worried scientists created a model that could help them figure out where those meteorites might surface. This model was quite complicated, taking into consideration snow cover, surface temperature, the speed at which ice flows, and even the steepness of the terrain. After that, they ran simulations under various warming scenarios. It turned out that meteorites indeed sank out of sight as temperatures rose. To say that the researchers were upset is obvious. They didn't expect that climate change would affect their work so much. Even though those areas are below freezing, people still manage to ruin a crucial archive of the solar system. But let's get back to your meteorite hunt. If you want your chances to find one to be higher, travel to the base of mountains or outcrops where ice, which usually flows to the lower ground, is forced to move upward. But make sure to take your windbreaker with you. In those places, powerful winds brush away snow, exposing bright, vivid blue ice. Instead of melting, this ancient ice can change directly into water vapor, and it helps expose meteorites that would otherwise remain hidden. You need to hurry though. Meteorites at the surface disappear quickly. Even when temperatures are well below freezing, the rocks can still absorb some of the sun's heat and melt the ice. It's like they're creating underground, or shall I say under ice, tunnels for themselves, sinking and hiding from sight. Sometime later, refreezing closes the entrance to those tunnels, effectively trapping meteorites inside, tucked out of sight. Now, scientists admit it's very tricky to find working methods to spot meteorites. And if we don't hurry and develop such methods, we might lose between 80,000 and 250,000 space rocks in total. No wonder scientists are on a mission to find more meteorites. They're focusing on meteorite stranding zones. Those are places where meteorites often gather on the surface because of specific features of geology, ice flow, and climate conditions. As you already know, you can find meteorites on blue ice without snow cover. This makes meteorites easy to spot. But finding such hotspots is often pure luck. Or you gotta sit day and night, scouring maps and satellite images in attempts to spot blue ice zones near research stations. Let me introduce Veronika Tolinov, a glaciologist, and her team. They've taken things to the next level by developing a smart Antarctic-wide map. To do it, they've used machine learning and satellite data from NASA, the Canadian Space Agency, and others. This map highlights areas where meteorites might be hiding based on past finds and all kinds of climate and ice data. Apparently, the best places to find meteorites are along the edges of the continent and near mountains with blue ice. Unfortunately, it's not just the blue ice that matters. The temperature and speed of the ice flow are also super important. For example, if the ice flows too quickly, meteorites get swept away before they can accumulate. So, if you want to find a meteorite, you have to wait for very precise conditions. The surface temperature has to stay below 16 degrees Fahrenheit almost all the time. Otherwise, meteorites sink. You can start with the Allen Hills region. Yup, that's where our ALH friend was discovered. This area is kind of a meteorite gold mine with more than 1,000 finds. But there are even more promising places, like the Fimbulheimen Mountains, and no one has searched there yet. You might be the first. In any case, with this new map, researchers developed a where-to-go index that ranks the best meteorite hunting spots, making future field trips much more targeted. And with plenty of blue ice regions still unexplored, there are tons of meteorites just waiting to be found. So, what are you waiting for?
There's a place on Earth so dangerous that even the most fearsome creatures of today wouldn't last a moment there. It used to exist in what we now call southeastern Morocco, the land called the Kem Kem Beds. The story of this place stretches back to the Cretaceous period, about 100 million years ago. It might have looked like a beautiful place at first sight, a lush green forest, rivers glittering in the sun, until you meet some terrifying dinosaur. The lions or sharks of today are nothing compared to what the fossils show us. The Kem Kem Beds were dominated by terrifying predators, and above them all, 3 of the largest predatory dinosaurs ever discovered. For example, Spinosaurus. This dinosaur was unlike anything you can imagine, a half reptile, half monster standing over 50 feet tall, bigger than a T-Rex. This hybrid with a crocodile-like snout and a sail on its back hunted the forests. But this dino could dive into the rivers, so not even waters were safe from it. It could catch huge fish, as if plucking them from the shallows. There was also Carcharodontosaurus, a carnivore with the name that literally means shark-toothed lizard. Its razor-sharp teeth could slice through flesh with terrifying ease. This monster stood almost as tall as a house and was faster, stronger, and more aggressive than nearly anything that had ever walked the earth. There was also Delta Dromedus, a raptor-like dinosaur built for speed. It was a quick-moving ninja that stalked its prey with horrifying precision. Oh, and the skies were a fun place too, with all these pterosaur creatures flying around. These guys are often mistaken for flying dinosaurs, but they were actually a different kind, more like close cousins of dinosaurs. These majestic reptiles soared above the Kem Kem beds and had wingspans that could stretch up to 30 feet. The fingers were feathery, with a fourth finger kinda like bats. They could glide through the air so easily thanks to their super light skeleton. But it wasn't just the dinosaurs that made the Kem Kem bed so horrifying. The waters also hid their own dark secrets. They were home to giant, terrifying fish and crocodile-like creatures. Their jaws were strong enough to crush bone, and they were lurking beneath the surface, waiting for anything unlucky enough to stumble into their path. One of the river creatures was Sarcosuchus, also called the Super Croc. Being about 40 feet long, it could easily swallow an adult human. Or better yet, it could take on a full-grown dinosaur and win. Its jaws snapped with unimaginable force, and no creature, not even Spinosaurus, was safe from it. Coelacanths could also hang out in the rivers. It was a monstrous predator that could easily swallow a huge fish whole. They had these creepy, icky fins that moved in a way similar to how human arms and legs move. And they could also kind of raise their heads like humans because of a special joint in their skull. Ew. Fun fact, we thought these monsters had gone extinct 60 million years ago, together with dinosaurs. But recently, we rediscovered them living and thriving in the Indian Ocean. Turns out they were just hiding in the deep waters. They probably didn't even notice the dinosaur asteroid or humans at all. Yay? Don't worry, over millions of years, they became basically harmless. They got 4 to 5 times smaller, even though they still weigh about 200 pounds. Just imagine what they were like back in the day. Kem Kem waters were also home to giant lungfish and other creepy aquatic creatures. So you couldn't even drink or take a swim safely without getting bitten by something. Whew, what a place. Even turtles there were the size of cars. Imagine trying to survive in a world where creatures like this are literally everywhere. And I mean everywhere. This place was unique not because huge beasts lived there, but because of the sheer number of predators. You might think, it shouldn't be that easy for all these predators to hang out in one place, right? And you're right. Seems like prey was scarce there. That's even more chilling. All the predators just wandered around, hunting whatever meager life remained. And if there's none, then fighting each other. For years, scientists have wondered why it was the case. Maybe that's just how life was back then. And all corners of Earth were crazy like that. Or is there something special about this place? Some even say that maybe it's just because we only found predators' fossils. Well, normal, friendly animals have disappeared, and that the fossil record might be skewed. But who knows? And the environment itself was just as fascinating as the beasts who lived there, just a bit more friendly. It's hard to imagine, but back in the day, this desert was a green paradise, humid and full of rivers. The heat of the sun scorched the land. The climate was hot, so hot that even the poles were warm. The weather there was extreme. Dry seasons followed by intense storms, which shaped the land and life. The giant rivers carved their way through this landscape. They stretched from the Sahara, emptying into the ancient Tethys Ocean to the north. If you were there, you'd see vast, interconnected basins, and beyond them, the central Atlantic Ocean. The floodplain stretched out beneath a sweltering sky. The rivers were just as wild as local animals, flowing lazily one day, but raging like furious beasts the next. At first, these rivers were powerful, carving deep channels through the land and creating wide sandbanks. But over time, they slowed down, and the landscape changed into shallow ponds and salt-covered flats. As water gradually faded away, it left behind a patchwork of wetlands and slow-moving waters. Right now, the Kem Kem beds is a vast, rugged desert where time has stood still for millions of years. If you visited it, you'd see a giant escarpment, its rocky face winding along the border of Morocco and Algeria, bathed in the sun's harsh light. Beneath your feet would lie layers of fossilized history. That's one of the reasons why scientists were long fascinated with this place. It must be one of the most comprehensive collections of fossils ever discovered in northern Africa. There are fossils from other parts of Africa, of course, like Egypt's Bahariya Formation. But they don't tell us much about life during this time, not like Kem Kem. That's all because those rivers we mentioned in hotter and drier places, they've eroded or still remain buried under the sand. The first discoveries from Kem Kem began in the late 1940s. A scientist named Schubert uncovered bony fish fossils among the escarpment near the Morocco-Algeria border. Just a few years later, a paleontologist, René Lavoca, took things to the next level. Traveling by camelback, he scoured the desert landscape and uncovered a real treasure trove of fossils. He found the partial skeleton of a massive herbivore dinosaur. Finally, at least one peaceful creature in the Kem Kem beds. This long-necked giant roamed the ancient river valleys and ate leaves like a good boy. For the next several decades, scientists only did small-scale fossil hunting expeditions to this place. There were modest discoveries made here and there. Then, in the 1970s, German paleontologist Helmut Alberti led his team to the Kem Kem beds, and that's when things took a wild turn. They uncovered fossils of prehistoric fish, crocodiles, dinosaurs, and pieces of the infamous Spinosaurus. Imagine being one of the scientists on that team. They were probably jumping from excitement. By the mid-1990s, the fossil game changed dramatically. Incredible new species were identified from the Kem Kem beds. Over the years, the discovery pace has only accelerated. Paleontologists, armed with new tools and techniques, have uncovered more fossils than ever before, and there's only more to come.